Hey everybody. Well, all right. So today we are going to be following up with coastal habitats. We're talking about tidal habitats. This is the third part of a three-part series. Today we're going to finish up with our discussion on seagrasses, and then we're going to transition into freshwater wetlands and dunes. So we ended last class period talking about seagrasses, and today I want to talk about some of the species that are found throughout the Gulf of Mexico and some into the Caribbean. Um, so one of the species that's also found in Galveston Bay, although in very limited amounts, is Thalassia. Sometimes the common name is turtlegrass, so oftentimes you'll hear it referred to as turtlegrass. Very common in the Caribbean and around Florida, where it forms extensive meadows. But in Galveston Bay, it's really only found down in Christmas Bay, which you know is fairly south of the very west end of Galveston Island. This is a protected bay, so that means it doesn't get boat traffic. The water is very shallow, and this is one of, actually, when you talk about seagrasses in the Galveston Bay system, this is an area that's very well known for seagrasses, and that's part of why it's protected. The water is very clear, again, very shallow, so there's a lot of light penetration. Thalassia has these long, broad leaves that are sometimes grazed on by green sea turtles, hence the name turtle grass. It does not tolerate low light conditions very well. And, one of the limiting factors for turtle grass on the upper Texas coast is the fact that our water tends to be pretty turbid, right? We have a lot of water and sediments moving out of our rivers, moving down along the coast from the Mississippi River. So you just don't find it here. Plus, well, the shallowness of the water is also a factor. So another species, again, not very common in the Galveston Bay system, is Halophila. This is commonly referred to as stargrass. It has this distinctive whorl of leaves that you see here. So you see these five leaves, has a very obvious midrib and veins on the leaves. And so here you can see kind of along a rhizome here. You I have not actually ever seen this personally, but I do know that it can be found along the backside of Galveston Island, particularly in the embayments along Galveston Island State Park. Okay, so another is Haliduli wrighti, or shoal grass. This is a recovering species in Galveston Bay. It's very similar in appearance to rupia that we're going to talk about next, but the leaf arrangement is a little bit different. Haliduli leaves are clustered from a single node on a rhizome, which you can see down in this image here. This is a very fast-growing species and can proliferate, particularly in nutrient-enriched conditions such as this. In some cases, there have been efforts to actually purposely add nutrients in order to stimulate recovery of these beds in some areas of the bay. So usually haliduli beds are, again, they grow in shallow water. And in a lot of the areas I've seen them in, where they're recovering along areas we have restored, or along some of our preserve sites in West Galveston Bay, um, you'll actually see those beds from the air. So I do drone imagery with some of my research, and you can actually pick out those beds from those aerial images. And they're usually fairly closely adjacent to those Spartina beds, in part because that's a little bit shallower there, so they're getting more light penetration. Another species is commonly referred to as widgeon grass. This is Rupia maritima. This is common both in fresh and brackish waters of Galveston Bay. Sometimes I've heard this referred to as ditch grass because you'll find it in growing up into ditches off of the bay in very fresh water. It can be mixed with haliduli when the waters are brackish or a little more on the fresh side, and it is ephemeral. So Rupia, again, is very similar to Haladuli, but in this case, the leaf arrangement is different. And so, as you can see in this image here, Rupia leaves are wider at the base and they taper to these long pointed tips. And they arise alternately from the shoot. All right. So, which of the following is not a feature of seagrasses? Would that be parenchyma in the leaves, lignification, hydrophilic pollen, or vascular tissue? Well, if you answered B, lignification, you would be correct. Remember that lignin is a substance that occurs in the cell walls of many plants that gives those cell walls rigidity that allows most flowering plants to grow upright towards the sun. And in seagrasses, that is not to their benefit. So their adaptation, lacking that lignification, allows them to be more flexible in tidal currents, which allows them to be able to persist in more extreme conditions. Tell me this, are seagrasses typically found to have more below ground or above ground biomass? Or rather, this question, typically do they have more below ground biomass than above ground biomass? Well, if you answered, oh, pardon me, true to this, that is in fact correct. They have extensive root biomass. Again, very important for the ecosystem services that they provide to their biologic communities. But again, that can be problematic, especially in stress conditions, because it takes a lot of energy. So in order to support all of that biomass, considering only really a small portion of their biomass is actually photosynthesizes. Okay, so let's transition now from seagrasses and let's talk about a little bit about freshwater wetlands. So freshwater wetlands typically fall into one of two categories, either marshes or swamps. We've talked about these before. What's the difference between them? Well, it has to do really essentially with whether or not they have trees and to a greater extent, even how stagnant the water is or how still the water is. So swamps are typically they have a lot of trees in them. These the species of trees can vary, but it's not uncommon in our area to see things like cypress trees, especially as you get up into the upper part of the Galveston Bay system. Marshes, on the other hand, are predominantly composed of different types of grasses. They're typically lacking trees. So that might include Spartina alterniflora or Sporobolus, as we've talked about, but it might include other things like different species of rush, like Scirpus. So that's the primary difference between those two. Where are freshwater wetlands? Well, they are, of course, you find freshwater wetlands all over the United States, but there is an extensive distribution of these along the coastline along the Gulf Coast and up through the southeastern Atlantic coast, extending inland quite some distance. There are some deep water habitats in there as well, where you'll see lakes or in some cases impoundments. But you can see relatively there's a lot of wetlands there. So the types of freshwater wetlands are defined primarily based on their landscape position. So lacustrine wetlands are located along the edges of lakes primarily. So this is often emergent vegetation that we refer to as littoral, meaning the edge of that particular habitat. So for an example, a lacustrine wetland on a lake or a swamp might be it's probably going to be dominated, as I said earlier, especially in the upper part of the Galveston Bay system, by cypress, which is a taxodium species. These are very long-lived trees. I've seen some up in the northern part of the bay that are estimated to be well over 300 years old. Um, they are characteristic for having these knees, cypress knees, that lends stability to those trees. You can see that down here in this lower picture, but it's also important for gas exchange. And they depend on these dry periods for seed germination. Okay. So when they drop their seeds, they need that dry period in order for that to happen. Um, Submerged and floating vegetation is in the deeper water habitat. This is called limnetic habitat. So if you see those two terms, littoral versus limnetic, it describes the relative position within that freshwater body. So this would be limnetic habitat here. Okay, so again, you can see these types of habitats if you venture up into the upper part of the bay. I think I've recommended this park before, and there are others, but I really like Jesse Jones State Park. There's a great walkway there, so if you get an opportunity, it's a great afternoon trip up there and beautiful walk out through the cypress. Here as a so this is in Florida, and this would be a marsh, right? So you see it's predominated by grasses, and but they do have cypress groves that occur in Florida as well. Again, both of these wetland types, these freshwater wetland types, are predominant all around the Gulf Coast. Again, up the southeast part of the Atlantic coast. Um, they are threatened, however, like most freshwater wetlands across the United States and across the globe. They're threatened in many instances by conversion of one type or another. In many parts around Galveston Bay, a lot of that conversion has to do with converting to residential or urban types of environments. But agriculture can, in fact, play a significant role in terms of the impacts of these habitats. That can include water diversions that may either flood these or drain them. And then also things that actually turn over the soils. So in some cases, rice fields. So where you've had historic wetland areas that are good for supporting rice. Unfortunately, when you convert them, they oftentimes won't support other types of plants that historically would have grown there. So you'll also see palustrine wetlands. These are non-tidal wetlands, and they're not expressly associated with a lake. So you can see different examples of these, and we do have these all around Harris, Galveston, Brazoria, Chambers counties. These can include things like depressional wetlands. Now, I know I've mentioned in class before prairie pothole wetlands. And so these prairie pothole wetlands tend to be, these are considered to be isolated, they're distinct, they're small. Our prairie potholes on the Gulf Coast are perennial, so you'll see them throughout the year. They do, however, how prominent they are is dependent on how much rainfall we're getting. They can, in fact, dry out for short periods of time. They're often connected to groundwater underneath the soils. And they have been extensively impacted by agriculture over the last 100+ years, especially in rural areas around Galveston, Brazoria County, some in Chambers counties as well. Now, sometimes you'll hear prairie potholes referred to in other parts of the country, and in those cases, the way they're formed can be a little bit different. Here along the Texas coast, those potholes are formed by the deposition of the sediments. You know, a lot of the geology of our area is sedimentary, and when sediments settle, they don't settle necessarily uniformly in a flat line. When you actually, I mean, it seems that way when you're looking at them with your eye, but up close, you can see that there are inundations in there, and that's what forms those little prairie potholes. However, in other parts of the world and in other parts of the United States, in some cases, those are formed by glaciers. So those glaciers, when they extended, would carve these depressions from their weight into the soils. And then as the glaciers receded, they left behind those depressions that were underneath the ice. So either of those can be referred to as pothole wetlands. Now, there are other types of these palustrine wetlands. The second type are ephemeral, and these would be vernal pools. These are typically very small, or playas, which are a little bit larger, usually larger than an acre. Um, and these tend to be very isolated to the point that the organisms that you find there oftentimes are endemic to that specific pool, right? So many are threatened or endangered species. An example is the fairy shrimp, which is endemic to a specific vernal pools, but there are others. And so I would say these are not as common in our area as you would see. These are more common in, again, in my particular practice, I've seen these more out west than I've seen them here in the southeast. Um, Not to say they wouldn't occur here, but just not to my particular experience. So you might also have riverine wetlands, or typically referred to as riparian wetlands. Riparian wetlands do, in fact, have higher water flow because they're occurring along these streams or rivers where you have a constant movement of water. Now, this can be along tidal rivers as well, like we have here in Galveston Bay, the Trinity River being a good example, the San Jacinto River, Clear Creek, Dickinson Bayou, all of these can in fact have these riparian wetlands along. They are really important for capturing and converting nutrients before they get into the water. They also provide shading along the side of the water, which impacts temperature by lowering temperatures, which helps then in turn improve the retention of dissolved oxygen in the water, which in turn helps improve fisheries habitat. So again, most of these riverine wetlands are in fact forested, and they again tend to have higher water flow than lacustrine or palustrine types of wetlands. So lots of examples of those once you get up into the upper part of Galveston Bay. So come up to Clear Lake, go to Armand Bayou, you'll see a whole lot of those along the bayou. There's a really good close example to Galveston. Now, tidal freshwater wetlands occur in areas that are upstream in rivers, but that drain into estuaries. They're near marine water, but they are in fact typically out of reach of the tidal range of saltwater. So usually you're going to find salinities below 5 parts per thousand. And remember, 5 ppt or 5 psu if you can, or 5 milligrams per liter. Choose your choose your unit. Typically, so five parts per thousand is actually drinking water standard in the United States, but it is also extremely fresh. So that means that you are typically going to find those habitats are dominated by freshwater species, and you might find facultative saltwater species like, again, Spartina alterniflora, which is very facultative, and you will find it way upstream in Armand Bayou. Now, one of the things I will say is that in these tidal reaches, it is very plausible that you will see high salinities in these areas on occasion. So when we have extreme droughts during storm surges, you can see salinities that get up over 16 parts per thousand, which remember is kind of a break point for where you move from freshwater organisms into brackish and saltwater organisms. So we have seen that in the last few years in the upper reaches of Armand Bayou when we've had these severe droughts. So even though the salinity is usually below that and the community characteristics tend to reflect that, do understand that because they are tidal, because they are connected to these estuaries, which are then in turn often connected to larger bodies of saltwater, saltwater penetration up into these bodies of water is in fact possible and does happen from time to time. About three-quarters of the tidal freshwater marshes in the United States actually occur here in the Gulf of Mexico, in part because of the topography of the Gulf. Okay, so now we're kind of moving back to this coastal area. So let's talk about sand dunes. Sand dunes are really interesting in and of themselves. And we've talked a little bit about sand dunes when we talked about some of the topography of Galveston Island. Remember, we talked about the Chenier Plains. We'll touch on that again. So this is an image of dunes along, I believe this is along West Beach in Galveston. Dunes are extremely fragile habitats, on par with some of the very arid, fragile habitats that you'll find in the Western United States. Um, and they can be impacted by a whole variety of activities that otherwise might seem relatively gentle, like even people walking across the dunes and displacing plants because of the how soft the terrain is. Um, Things in some dunes, so there are some parts of the country where you see extensive outdoor activities that include things like motorsports. And, I'm a motorcycle guy, but you won't see me riding in the dunes because so four-wheelers, those types of activities can really disturb those dune habitats. And if it occurs regularly enough, like it can in other areas, we see the same thing in some forested habitats as well. You can see some significant impacts. And that's why a lot of these areas, many of them are protected specifically because number one, they are oftentimes a primary barrier to the ocean when we're talking about storm surges. So they help break up that storm surge from incoming storms. But again, they're a unique habitat from all of the other habitats behind those, and they protect those habitats and then any houses or other types of things that are there. So coastal sand dunes are formed by interactions between sand, wind, and waves, right? And they have global distribution. So you'll find sand dunes all over the place, from all across the United States, through areas you wouldn't think to find sand dunes up in the Arctic, down to the Antarctic. So they're everywhere and they can range from large to small. I know in some areas, I spent some time in Baja some years ago, and there are some really large wind-shaped sand dunes in that Baja Peninsula that dwarf anything we have along the Texas Gulf Coast. Um, they're again very common along the Gulf Coast. If you spend any time here, you know that to be the case. So when you look at the structure of sand dunes, so let me follow me from out here. So this would be if you were looking at a sand dune along Galveston Island. This would be the Gulf of Mexico over here, right? And so you would come up on the first dune ridge, and this is the primary active dune. Um, this dune is closest to the ocean. It tends to be the most dynamic. Thus, it has the lowest species diversity, and it can be subdivided, as we're going to see, into these various community types that include colonizers, soil binders, and competitor stages. Then you get what's referred to as a swale behind that. All right. And this is the hollow between the dunes. And it's often a low elevation, close to the water table type of environment. In fact, like we've talked about before, and we'll see again, some of the swales on Galveston Island actually have direct connection to shallow groundwater right below the surface and down to the highest significant aquifer, the Chicote Aquifer that runs along the Gulf Coast there, including under Galveston Island. You will see marsh plants. And again, if they're not connected to saltwater, you'll often see that these are freshwater pools because they regularly fill with rain. And there can be very high diversity there, in part because of the fresh water, but also because that particular area where those swales are relatively protected on both sides, right? So they don't have as much effect from the wind, and they're not in that immediately active area close to the Gulf of Mexico. Then you'll have these secondary or fixed dunes. Now, at one time, these would have been primary or active dunes. Okay, they occur inland from swales. They're very less mobile than the active dunes, and again, because of that, because they're less mobile, there's higher diversity there. So, looking again here at another photo from beachside, you'll see here we've got moving from the water. We've got the seaweed deposits. This is really part of the high tide rack line. And so here in the Gulf of Mexico, we're very affected by the sargassum seaweed from the Sargasso Sea. And you'll see that wash up periodically, sometimes huge mats of it, huge amounts of it. That seaweed is actually really important in terms of how it adds structure to the dunes. Um, Right behind that, you'll see the primary dune. And so this is sand as it slowly moves from the Gulf and starts to accumulate on the shoreline. This is that active dune, right? And you'll notice as you look at it that there's a lot of exposed sand here. This sand is loose. It is very easily blown around by the wind. And consequently, it's a rough environment for plants to be able to establish. If you think about what you learned about ecologic succession, primary and secondary succession in some of your earlier biology classes, you would know that when you have a severe disturbance, it can take even up to centuries for these plants to be able to establish a foothold. With secondary succession, where you have a disturbance, that might be a hurricane that takes out this primary dune, it might take a while for that to occur, but it is going to come back. And there are a couple of distinct species we're going to talk about that help this process occur here along these primary dunes. Now, right back here, and it may be a little difficult to see, but you can kind of see there's a ridge here, there's a ridge over here where the secondary dune is, and between here is a swale, right? And so this is a low area where, again, you can see there's more plants, there's less exposed sand. And so this is an area that's going to have a little higher diversity and is going to be more stable. This secondary dune would have been a primary dune at some point in the past. Okay. So again, you can see this. This is all part of the Chenier Plains. In an island environment like Galveston, a lot of times you can really see this. So you've seen this slide before where you can see the old remnant dune swales here. I'm sorry, I'm turning my head because I'm trying to get my head level to the picture. In any event, you can see here where these remnant swales are that have filled with fresh water. You can see them here on the beach side of Stewart Road as well. And so these swales on the beach side don't always have as much fresh water as on the bay side. In part, this tends to be a little bit lower back here than it is right here on the beach side. This is still receiving active building from the Gulf of Mexico. We do have sediment and sand budgets we talked about. So material that moves up and down the coast, it's going to accrete in some areas. It will erode in others. We have had an effect on this with things we've done along the coast, like we've talked about previously. Nonetheless, you can see this here. And if we look closer, you can see some areas that are still isolated. So this little area here would be one of those remnant swales that has fresh water in it still. Here, where it has connected to Eckerd Bio, this may be fresh up at this end where it's a little bit higher, but during high tide events, you may see brackish conditions clear up into the end of this past Settegas Road. So it really depends on whether they've lost their isolation and become connected to the bay or not. In some cases, we've enhanced that, as we talked about here in Spanish Grant. They actually dug their canals where these historic swales were. Okay. So here again, we're talking about ecologic succession. So you've got this primary dune, right? And so this is material that gets pushed up as part of the rack, part of those sediment budgets that are moving up and down the coast. That it can include Mustang sands, it can include coral sands, it can include clays and even silts from riverine deposits out into the Gulf of Mexico. Can also include a lot of organic and plant material. So seaweeds, again, like the sargassum that you'll find down there at certain parts of the year. Again, the seaweed is really important, particularly that it adds structure and nutrients to the sand that makes it a little easier for plants to colonize. Um, Embryo dunes, so when these dunes are first formed, before they have really any significant vegetation in there, again, they're very fragile. The conditions there are very harsh, so there's a lot of wind. There's salt spray coming off of the ocean, shifting sands. But again, they're wind blown, so they are going to move around, and they're very dry. So again, this is it's a very harsh environment and really hard for plants to establish in until you start to get a little organic material, some nutrients mixed in there, and a little bit of structure that'll help lock that down. Again, one of the things that sargassum does as it starts to accumulate. Once that starts to happen, you'll see colonizer species start to move in. And so using nutrients from rack material that gets mixed up into that sand or sometimes is covering that sand, there are some vascular species that will start to colonize. Mostly these are annual species in short growth forms. They're in their short growth forms again because these are not nutrient rich environments. They're harsh environments. There's a lot of disturbances. They have to put a lot of energy just to even be there, right? They also tend to have very lightweight seeds. Why would that matter? Well, in part, it's going to matter because of seed distribution. So lighter seeds are going to travel further. They're going to be able, that will help them colonize more area more quickly and be able to find areas that are more suitable for them. So that becomes important in terms of persistence because, like I said, sometimes these are annual species, often they are, and in some cases they don't persist. So if we had a big storm come through and that primary dune, that first dune along the front of the beach, if it gets knocked out, everything that was there is dead. And so these species being able to distribute their seeds across a wide area is going to allow them to persist and then recolonize at a later time. A lot of these early species belong to the grass family, so Palaceae, and then you will see other species there as well. A couple of example species is Sporobolus virginicus. So Sporobolus is one of those grasses. It likes those higher, drier habitats, and it has this very long, thin inflorescence. Again, here's those very light seeds. Another one that you probably will recognize or should recognize is Distichylus spicata. Again, this is a very hardy species, and it is considered one of those colonizer plants. That's another reason why you'll find it in some of the harsher conditions in tidal wetland environments mixed with other plants. But it is one of the first things you'll see grow up on dunes in a lot of our environments, including on Galveston Island. Um, Colonizer species are then followed by soil binder species. So these have slightly heavier seeds. Again, still their short growth forms. I don't know why I'm tongue-tied this afternoon, but they're in their short growth forms, and they tend to have a longer growth period. In fact, they oftentimes are perennial. An example of this would be Ipomoea. There are a lot of Ipomoea species, by the way, throughout the Galveston Bay area. They're often characterized by across those species as having these really beautiful little purple flowers in there. So again, these guys actually, because they're perennial, they're able to offer a more substantive protection, but they need those colonizer species to kind of lay the groundwork, right? To start to bind those soils down start to stabilize those soils a little bit so that these binder species can come in and then really start to convert those soils. These are then followed by competitor species. Again, relatively light seeds so that those seeds are going to be able to move. These, because now we're talking about environments that have quite a bit of organic material in them now, can take a taller growth form, and they tend to be perennial. These species, like Spartina patens, for instance, that you've seen, Panicum is another one that's very common. These are taller. That helps with wind erosion. So it starts to protect even the areas here that are still exposed. They're better protected because of the height of those particular plants. A couple of these species that you'll see are panicum. You will also see Phragmites. Phragmites is an introduced species. And so there are hazards associated with introduced species, but they are fairly common throughout the Galveston Bay system. So you will see those. Now, if you compare secondary dunes to the primary dunes, these are much more mature, right? They're much further from the active shoreline. In fact, the primary dunes are in some ways sacrificial because they protect these secondary dunes. So if you have a storm event that comes in, if that primary dune is damaged in some way, the secondary dunes are protected and they have a lot of those colonizer species associated with them, which then allows them to recolonize when a new primary dune starts to form. So this is part of, again, that kind of mosaic of habitats that's really important to long-term stability and persistence. Eventually, given enough time, you'll start to see shrubs move into these areas. When you're down in East Bay Lagoon, when you're looking at those, you'll tend to see some of those more shrubby species occur in there as well. Um, like many of these plants we've talked about, many dune species have roots that are very deep. And this is actually true of a lot of grass species globally. But those deep roots are really important because they help bind the sand together, they help stabilize the dunes, they add organic material. In some instances, we've talked about this with the Spartina alterniflora in wetland environments. They actually can add organic material, which makes those soils stickier and more erosion resistant, in these dunes, these long roots can actually be beneficial in terms of carbon sequestration as well. There's been a lot of interest in uh, panicum species and other grasses as a fuel source, a renewable carbon-friendly fuel source for biofuels because the surface can be harvested. They grow back very rapidly, but the deep roots sequester a lot of carbon down into the soils. So they have kind of a dual purpose. Here in these dune environments, though, they're particularly important at dune stabilization, soil stabilization, and later colonization by more mature complex habitats. Again, dunes are very dynamic. You can walk along a dune that'll have a nice slope, come back in a week after a big storm, and you might see a lot of erosion, even where you have some very shrubby species that may have been protected by that initial dune, depending on the amount of erosion. Some very mature habitats can become exposed under extreme enough conditions. So here again, um, this is in South Padre Island, and to highlight the dynamic nature of these dunes. So you're looking at some park facilities here. So these are little covered picnic areas, and so these little arrows kind of point those out. And I want you to see this next slide. So these are these areas after Hurricane Harvey in 2017, and you can see the difference here. So the environment can change very quickly. You know, the plants can only do so much. The more plants there are, the more mature the system is, the more likely it's going to be stable. But in these dune environments, they can move very rapidly under very extreme conditions. And that's probably why we have the saying, don't build your foundation on sand. So take heed if you're thinking about building a beach house on the west end of Galveston Island. All right. As I said, these are very stressful environments. There's a lot of salt spray. There's not a fresh water supply. They're nutrient limited, high wind, shifting sand, temperature fluctuations. They are tough for plants to be able to establish. So the fact that this does occur over time is really a testament to just how hardy and well adapted these plants are to this particular environment. And again, they're helping each other, right? Those colonizer species lead to soil binders that lead to other species and so on and so forth. And that's part of that process of ecologic succession. That looks different in different habitats. This is what it looks like in these dune environments. So, looking at this, looking at these species, so these are a couple species I introduced a couple slides ago. Would you consider this to be a primary or a secondary dune? Well, if you answered secondary, you would be correct. So what you're seeing here are these are soil binding plants that are going to typically be found on they're going to be found on these secondary dunes. You'll notice there are more species here. Some of these species, the panicum in particular, is a taller species. So again, this implies maturity dune that is no longer on the beachfront, but is protected by another dune and probably a swale as well. Okay, so as a recap, you should from this presentation be able to, so if you look at the entire thing, all three of these tied together should be able to describe patterns of zonation, species distribution, et cetera, in these vegetated coastal habitats. You should be able to identify some of the key species that are characteristic of these habitats. You've seen some of these in the field, so do make use of what you've learned in your laboratories as well. These go together. And then understand the unique features and adaptations that facilitate survival in these types of habitats. Okay, so you have a test coming up. So this lecture exam is going to be occurring next week. So all of next week is set aside for this purpose. The exam is going to be on Thursday. It is a 50-point, 25 question multiple choice test. And we are going to have a kind of a review day on Tuesday, the 19th, where I'm going to present you with 6 challenge questions. Actually, you'll have those before class. I'm going to put them up on the challenge questions will be up on Canvas, so you'll have an opportunity to look at those. We're going to spend the entire class time reviewing those. The multiple choice questions, a lot of that is going to relate directly to these challenge questions that we're talking about in class. So the kind of things that we're going to draw on, we've spent a lot of time talking about stressors moving from the low to the mid to the high elevations. You should be able to identify those, and you should also then be able to identify adaptations that the plants have in relation to these stressors. Okay. You should be able to identify different types of habitats and some of the features of those habitats that might make them more stable or less stable. So for instance, a salt pan is this a steady state, unvegetated environment that's going to be that way for a long period of time, or is it not? You should be able to answer those questions from what you've learned moving forward, and I would encourage you to go back and review that. So an example of the kind of things you'll see on the test and what we'll talk about in the challenge question. So these panels here, so I'm giving you some graphs, right? These panels depict the relative abundance of 2 different tidal wetland species along an elevation gradient. Which species is more likely to be well adapted to flooding stress? What species might this be, and what are some of the key adaptations? Well, all right, so you got 2 different wetland plants, and so you've got your soil elevations here in centimeters. So whatever this is growing in a lower elevation. Whatever this is growing in a high elevation. So thinking about what you've learned, what species, what species might this actually be? Well, in a lower environment, this is going to have more flooding stress, right? Where in a higher environment, this might have more salt stress. Well, what species have we talked about that might do that? Well, for example, this could be Spartina alterniflora, right? It would do well in that more flooded environment, but it could be other things we've talked about as well. And what kind of adaptations would it have, given that it's going to see flooding stress? Again, something you should be able to speak to. Which of these two is more likely to be able to adapt to high salinity stress or be well adapted to that? And again, here, talk about what this is, right? Um, which is likely to be a superior competitor against other plant species? So think about what would make these plants more competitive or less so. And again, we've talked about some of these particular characteristics reflecting the abiotic environments that we have looked at. All right, so I might give you a graph like this. Where is a mangrove seedling surviving more, and where might it where might you why might you find mangrove seedlings where they are? So in this instance, the mangrove seedlings are going to be surviving more in those mangrove stands. Why is that? What abiotic stressors might contribute to higher mortality in a mudflat compared to the groves themselves, right? So you need to consider things like elevation and exposure that we've talked about. All right. So, um, you do have a weekly quiz this week on this lecture that you've had today. There is no quiz for next week because we're going to be doing review and then you're testing all of next week. So, review discussion section on Tuesday and then your test on Thursday. So, in the meantime, do reach out to me if you have any questions, and I will look forward to hearing from you, and I'll look forward to seeing you next week.